So this is an expression. There's no equal sign. Later on, we will solve for a value. Then we have what we call an equation. So for example, right now we might get x plus 4, but later on we get something like x plus 4 equals 3. What's the value of x? -1, right? You guys have been doing that since like grade 4. I know that because my daughter does that. But what we do is we do some harder math, so we apply things or look at it differently. Okay. So what we want to do is just write a polynomial for the situation. We got Digger Dan. He pays $5 for each saw, $10 for each hammer, $60 for each power tool. How can we write that using math and letters? Yeah. Now when you go to, we should use lowercase letters, but I don't really care too much if you don't. When you go to the store and buy your 5 cents for a gumball, right? So it's 5 cents. What happens if you buy 10 gumballs? Yeah, you'll multiply it together. You do that all the time in your head, yet some of you don't get. If he buys 10 saws, it would be $5 times 10, right? $5 times each one. Connor, something you want to add? Okay. So it would be $50 for all those saws that he bought. Same idea. It goes back to the candy store. Okay, so when you're struggling with these word problems, think about when you're a wee little lad or lass and went to the candy store and bought your favorite gumball. No, it doesn't work for you? Okay, anyways. Okay, go ahead, write the polynomial for this one. Underline the important stuff as you read it, please. Underline what's important. I have a question for you. If he tows absolutely no cars in one day, how much is he going to get paid? Okay.
Depends. Do you mean showing up for work as he goes there?
Yeah, he goes there, sits there, twirls his thumbs, no cars to tow. How much does he get paid?
How long does he work?
Oh, he works all day.
$20. So does he get $20 just for working, or does he get it every hour?
Just for showing up. It's not paid by the hour. It's piecework. That's just like if, so if you sell TVs, right? You used to get $40 a TV. If you sell no TVs, you don't get paid.
It's commission.
Right, but I'm trying to relate it to this, right? For example, a lot of agriculture workers, they get paid piecework. How much per pound, right? So you go in the Okanagan, you're picking peaches or pears or apples, you get 10 cents a pound. I don't know what it is. That's piecework, okay? So this guy, he just gets $20 for showing up plus something else. This will never change. What word can we use to describe a number that will never change? Constant, okay? This will change. Right? If he tows one car, how much does he get paid? Tows 2 cars? 3? 120. So what would that be? 40 times t. That's the coefficient. So the cost is the coefficient, the tow's the variable, plus $20 for showing up. Okay. So then a question like this might pop up. How much do you get paid for towing 12 cars? So the formula is 40t plus 12. Then we substitute. So 40, sorry, I don't know why it's 12, plus 20, thank you. Times 20, oh, I did it, times 12. Let me slow down here. Plus 20. Then we go and solve it. Put your calculator away. What's 4 times 12? 48. So this will be 480 plus 20. Pretty good day, made $500. Okay, that makes up for those days when he gets $20. Okay. Questions, comments, what do you guys think? Okay. Try the next one. Big Mac. $3 for a cheeseburger, 2 for a hamburger. What's the polynomial? Underline the important stuff. So you should get 3C for cheeseburgers plus 2H for hamburgers. You could have used X and Y as long as they're different letters. I didn't really care. But the textbook likes to use letters that are descriptive, right? So C describes cheeseburger, H just a hamburger. Okay, write the formula out. Substitute in. I use brackets to show my multiplication. And then solve. Okay, so it costs $33. How many people got that? Any questions? Okay, next one's a little harder. Read it. Now, this is Rugby Mad New Zealand, but you can really substitute Hockey Mad Canada. Oh, how about your textbook's going to do that? All right, go for it. Okay, so 4W, 4 points for a win, 3 points for a tie, and 1 point for a bonus point. So it'll be 1 times a B for a bonus point. Okay, that's a little bit weird. They do bonus points like that. All right. In hockey, it's, was it 3 for a win, 2 for an overtime win, 1 point for 2 for a win, 1 for the loss. Like, yeah, okay. All right. I think in the textbook's a little old, so I don't know if they're doing that. Okay, so just read the textbook carefully. So then to substitute in, hey Chris. All right, 1 4 matches, 4 times 4, plus 3 times 2, they tied, plus 3 bonus points. Now look at this, 2 games that they lost. Do you need that information? No. Okay, so sometimes they do that to you just to really mess you up and have fun. So 16 plus 9, 25. Is that right? Nod your head if you got 25. Yep. Who's that? Sydney? Yeah, see, sorry. Or did you just forgot it? Oh, okay. I said nod the head, not hands up. You fooled me. All right. So this is what I want you to do right now. I'm going to give you 10 minutes absolute max. Page 180. Numbers 21 to 24. 26, 28, 30. Okay? So, you need to have, when we draw these, one's shaded, one's not. That is what we call a zero pair. Rectangles. One is shaded, one is not. And the squares. Same thing. Okay, a zero pair. So there's 3 different ways. Now we're going to be adding zeros and taking zeros away. We don't have the number 4 plus 0 plus 0 plus 0. We just have the number 4. Okay. You were right. Like, you've never seen that, have you? You ever seen that plus 0 plus 0 plus 0? No, because you would just take it away. It's useless. That's the same with algebra tiles. Sometimes, though, we go backwards. Did I change any values here? Has any values changed? No. 4 equals 4 equals 4. Okay. But we did change the appearance, and we have to do that sometimes with the algebra tiles. Okay. Any questions? Okay, I thought Victoria would be back by now, and we need her for the next part, so let's just wait for her. We're adding these. We don't change it. You just tell me how many x squareds you have, how many x's. So we actually had only 3x squareds plus 2x's. Sorry, not 2x's. How many x's do we have? 5x's. So when you were looking at your desk, this is what you saw. 3x squareds. You should be writing now, so I know why I hear pieces moving. And 5x's. So you didn't get 8x cubed. There's no cubes there. You didn't make a new shape. Okay? Just tell me what you had. That's all you have to do. Don't change things. So, notice how we group them? We group by shapes. Okay? And so shapes are what we call like terms. So like terms have the same letters and exponents. Okay. So this means they have the same shape. Oops. I screwed that up. Like terms have the same shape. This means they have the same letters and the same exponent. So you didn't add your x's to your x cubes. Okay. So way back when I was a math student, they would say, well, how many x squareds do you have? How many are there in that expression? 3. So you'd write down 3x squared. What do you want? Okay. How many x's do you have? 3. And how many 1 tiles do you have?
3.
And what's really? Because here I have how many? -2. Here I have -3. So I'd have -5. Notice how you include that negative sign? That's kind of important, isn't it? How you guys doing? Thumbs up, down in the middle? Okay. So, talking about like terms, which terms are like? Your x's are alike. Okay. Your x squareds are alike. Okay. And then you have xy terms. Notice I'm using triangles. Oh, is 7xy different than 7yx different than 6xy? xy? Do they have the same letters? Same exponents? They're the same. Okay? But these are unlike because the exponent is on the different letter. Okay? So we can't combine unlike terms. If we have 3x squared plus 2x, that equals 3x squared plus 2x. An example of unlike terms, 2 cats plus 3 dogs. That does not equal 5 cat dogs. Okay, that's what you're trying to do. So it does not make sense. Okay. But 2 cats plus 3 cats, what does that equal? See how easy this is? Use these analogies to help you to stop making mistakes, okay? Okay. So when we're drawing this, you want to match them up and check for 0 pairs. So Here we have 3x. Please draw that. Here we have a negative x. Draw that. Okay. Here we have a minus 3. And a plus 5. Okay. So I matched them up on purpose so I can remove 0 pairs. This makes a 0 pair. I circle it and cross it off. Right? We don't want to write plus 0, plus 0, plus 0, plus 0, plus 0. Get rid of it. Here we have 3 0 pairs. Cross it off. So what's left over? 2x plus 2. You guys okay with that? Okay. All right. Try this one. Okay, here's x squared. Here's a negative 2x squared. Okay. Then draw your x's. Try and pair them up. Now, if you want to draw your x's this way, there's nothing wrong with that, okay? Then draw your 1 tiles. Okay, so here's a 0 pair. Circle it, remove, circle those 0 pairs, and there's no more. So your final answer then is, Alouette, how many x squareds?
1.
And it's negative. How many x's? 2. Oh, and they are?
Negative.
And how many 1 tiles?
5.
And they are?
Negative.
Good. There's your polynomial. Okay. Thumbs up down in the middle. Awesome. So now what we're going to do is we're going to just make sure that we don't combine unlike terms as we do this without tiles. So let's start by combining our x squareds. Here's plus 4. Here's plus 5. How many x squareds do you have? Combine your x's. And combine your 1 tiles. How many people got that? Hands up. 9x squared plus 16x minus 9. Good. Okay. I'm not going to help you now. Go ahead and do number 6 by yourself. How many x squareds? Ethan.
Negative 6.
Good. Make sure you have that negative sign, folks. You gotta be very careful with your signs. Plus 4x squared minus 10x squared. How many x's? Xander? Good, negative 2x. So careful with your signs. And last but not least, how many 1 tiles? Chop meat? Oh, you know what? I totally missed that. Hold on for a second. What's 8 and 7? 15? But then it's minus 3. So it'll be 15 minus 3. 12? Is that right? Double check. Nod your head if you agree. Okay. Okay, so we gotta be careful. I totally missed that 8. Okay, so be careful with that. Question, Emma? Stretching? You guys are stretching class. Like, seriously, all you guys are doing that. Okay, now we're going to get a little harder. Well, I'm going to just change the letter on you. Now you're going to have d squareds, d's, and 1 tiles. Go ahead. Do number 7. And if you're really good, go ahead, do number 8. So what I've done is I added 1, 2, 3, 4, all 5 sides together. Okay. Then I do have to simplify it. 3 plus 4 is 7, and 5 is 12, and 6 is 18, and 5 is 23x. And negative 2 minus 4 is negative 6. Okay. So that's the perimeter. That's the expression. Say x equals 2. Find the perimeter. So I won't go back to the original. I would just substitute. Perimeter equals 23 times 2 minus 6. Right? We did that at the beginning of the class. So I actually assigned an x value. That would be 46 minus 6. So that equals 40. Okay. So sometimes we do find the exact values. Any questions? Okay. Next part's going to be easy. Adding. So each term of the second needs to be added to the first. So number 1, draw the first. Number 2, add each piece of the second. Then number 3, circle and cancel any 0 pairs. We've already been doing this, folks. Okay. So number 1, draw that. Okay. Number 2, draw the second one. You don't have to do a different color. I'm just doing that to show you. Good. How many do you have? Do you have any 0 pairs? No, you got lucky. No 0 pairs. How many x squareds? 3. How many x's? 5, I think, aren't there? 5. They're negative. and plus 4 little 1 tiles. How'd you guys do? Good? Okay, do the next one all by yourself. Go. First of all, draw the first one. So be careful. Okay, so circle your zeros and cancel them. And tell me what's left. Plate, how many x squareds?
1.
How many x's?
1.
1.
How many other tiles? 1 tiles? 3. So x squared plus x plus 3. Hands up if you got that. Awesome. Okay, so what I want you to do for this is I want you to write the addition. Okay, so tell me what it is that we're adding. And then I want you to go to the answer. You can cancel out your zeros this way by just crossing them off, okay? But first tell me what's in the brackets. That's kind of important. Kind of practicing what we did yesterday. So what's remaining? Negative x squared minus 2x plus 2. Any questions? How many people got that? Okay, good, 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 good. I just finished doing this with grade 10s. All right, this is such important stuff. Okay, so now we're going to complete without algebra tiles. Can't screw up addition. Absolutely can't. Okay, so it's remove brackets and rewrite. That's an important step, especially because we're changing it on you tomorrow. Then number 2, just add each piece. So you're collecting like terms. Okay, so 3x plus minus 4. And really we're adding a positive 7x, and we're adding a negative 8. But our double signs don't change anything. Okay, so really we have to add both pieces. Right? That's kind of what we did up above. Our signs don't change. Okay, tomorrow you see they will with subtraction. So all together, 10x minus 12. Okay. Try number 11. Rewrite, please. Your signs don't change. Oh, does it? Okay, can I see yours for a second? Let me just fix that. Thanks, Ethan. X minus 1. Okay, good. Thanks. Yep. Yeah. Go. Yeah, go, go, go. Yeah, you're late now. Don't blame me. So 4x squared minus 2x plus 3. Ends up, you got that? Awesome. Any questions? Okay, go ahead. Just do example 13 all by yourself. Don't do example 14. That's just the same stuff, okay? But do example 13. Okay, if you got example 13 done, then do the following, find the perimeter. Okay? So for the perimeter, you're going to add all the sides. Sorry? One teacher.